Greetings, Dr. Effendi. My name is Jonas Hanapita, and today I'm presenting my slides based on my research documented in the file Antimicrobial Efficacy of Yellow-Footed Polypo Microporous Xanthopus Extracts from Unimas Forest Reserve Against Plant Photogenic Fungi. My study evaluates the bioprospecting potential of local microfungus to address critical bottlenecks in agricultural disease control. For introduction, our agriculture sector relies heavily on synthetic fungicides to tackle the threat of fungal pathogens, which reduce yield production. So, for my study, I'm using microporous and topaz extract to create a bio alternative for the synthetic fungicides, which we are currently in need to replace synthetic fungicides. Now proceeding with problem statement, as we dive deeper into the issues that have been brought up by prolonged use of synthetic fungicides. Synthetic fungicides pollute the environment by leaving chemical traces and residue into the soil, which degrades the soil and it's toxic to the environment. Other than that, we need a replacement because there are rise of multi-drug resistant fungi. For sure, of course, it threatens agricultural and human healthcare. And now we are in need of biodegradable, eco-friendly alternatives. Okay, to address these issues, I have established the following research objectives. My primary goal is to evaluate the dose-dependent antimicrobial efficacy of locally sourced Micropus xanthopus extracts against destructive plant pathogenic fungi. This is supported by three specific objectives. First, to prepare sequential solvent extracts using methanol and ethyl acetate. Secondly, to measure mycelial growth inhibition using the poison food technique. And third, to determine the minimum inhibitory concentration or MIC against our target pathogens. Uh, to dive deeper into the research, I will address two fundamental questions on next slide. This investigation leads to two core questions. First, does the crude extract of Micropus xanthopus exhibit statistically significant dose-dependent antifungal activity? And secondly, which solvent will yield the highest concentration of active antifungal bioactive compounds? This study is significant as it provides the first baseline bioprospecting data for Microporous xanthopus harvested directly from the Nimas Forest Reserve. By mapping this species antifungal profile against tropical agricultural pathogens, we offer an organic alternative to toxic synthetic molecules. This directly supports the Global One Health framework by protecting soil, crop, and human health. From my literature review, it shows that macrofungal secondary metabolites such as alkaloids, triterpenoids, and flavonoids thus effectively disrupt fungal cell walls. A past study does demonstrate that methanolic extraction outperforms water extraction in isolating these active lipophilic compounds, but there are no research published yet for Saracan strands of Microporous xanthopus. To bridge this To bridge this research gap, I have designed a structured two-part methodology. For collection and extraction, I will collect Microporous xanthopus fruiting bodies from Minimas Forest Reserve using purposive sampling. The sample will be collected and washed and then oven dried at 40 degrees Celsius to preserve its thermolabile compounds and pulverized. Sequential extraction will be conducted using ethyl acetate and methanol, shaking them at 150 rotation per minute for 72 hours. Finally, the mixtures will be concentrated using a rotary evaporator under reduced pressure at 40 degrees Celsius. The end product will be extracted, then be subjected to in vitro bioassays. For the next part, I will test the extract against destructive agricultural pathogen genera. Two most common ones and readily available are Colletotrichum and Fusarium. Using the poison food technique, I will test the extract concentration ranging from 0.5 mg per milliliter to 5 mg per milliliter on growth agar. I will measure the daily radial growth of mycelia to calculate the percentage inhibition of radial growth or PIRG. The data will be analyzed using a one-way ANOVA and Duncan multiple range test at a significance level of P lesser than 0.05. Through this experiment, we can finally anticipate the key findings on for the expected outcomes of this experiment. I'm expecting three major outcomes. First is to determine which solvent yields the highest amount of potent antifungal compounds. Secondly is to get the exact dosage threshold for my target pathogen. And lastly, I'm expecting to validate local micropores Xanthopus strain as a highly viable eco-friendly biocontrol agent. And to ensure all these are completed on schedule, I am following a strict timeline, as you can see from next slide. For my sixth plan operation, it will start on September 2026. I will begin with sample collection and taxonomic identification. For October, I will do sequential extraction and then followed by pathogen culture and cultivation for November 2026. And in December, I will conduct in vitro bioassays. After getting results on January 2027, I will get all the statistic and ANOVA data. And lastly, I'll do thesis writing for final submission in February 2027. This sums up my project proposal.